Okay, we will start now. Can you see my slide? You available? Can you hear me?
Yes, sir.
Yes, sir.
Okay. We will have discussion. Actually, last week I have assigned 2 video. So part ni kita dah cover dalam lecture on Thursday, cascading and also step counter method. But there are a few things that I just want to like share lah. So for our discussion today. So mainly I already kept the questions in your Edpuzzle video, and also I pun dah bagi you YouTube link, okay, for the videos. Okay, because cascading method and step counter methods are very important, okay, especially in your design of your circuit. Okay, so cascading, dia ada cara dia nak buat. Okay, so if you already watch the YouTube video and also Edpuzzle, I think you dah tahu lah. So what are the step? Macam mana nak buat? Okay, so if you are still not sure, so I pun ada bagi assignment. The assignment 1, okay, for you to complete. One is for cascading, one more thing is for step. So maybe kalau you dah buat tu, maybe you have a few questions. You may ask at the end of the discussion. Okay, for today we will check, okay, some of the questions in your puzzle, okay, which I will consider like important lah, important for you to understand. Okay, so macam I bagi tahu tadi dalam tutorial, I think for the group. Okay, so next week kita akan buat midterm. Okay, midterm I will tell you when the date. So normally it will be 1 hour. Yeah, ada 2 soalan. Okay, so you need to macam biasa lah. So you need to do and submit. Okay, so in the given time frame. Okay, so kemungkinan besar soalan design akan keluar. So it can be classical method, cascading ataupun step counter, as well as theory questions. Okay, so it will be normally a combination lah. Okay, so you need to know how to answer. Okay. Okay, so before I go, so ada soalan tak related dengan cascading, so related dengan assignment or generally? So any question? Yeah, on the cascading method and also step counter method. Ada, tak ada. Okay, so I hope you all understand lah. So kalau tak faham tu, try to repeat the video until you get the full picture, okay, of how to design. But dia design subject, kalau tak tahu design tu, I think defeat the purpose. So either you tanya saya soalan, if tak faham, or you try to find in your YouTube video. Okay, so hari ni kita akan tengok. So since last week I gave 2 puzzle video, satu untuk cascading, satu lagi untuk step counter. So I'll try to discuss some of the questions available here lah. Okay, so ini adalah first question dalam cascading video. Friends, now ni satu-satu dah masuk. So what does the term cascading means? For your opinion, how cascading can be used in pneumatic or hydraulic circuit design? Okay, so siapa boleh answer? what does the term cascading means? Anyone? Siapa boleh try? Anyone there?
Can I try, sir?
Yeah.
It means dividing the one system into two subsystems. Pneumatic system, the circuit.
Okay. So what the term cascading means? I think ada dalam lecture note code yang ni. Cascading.
Cascading means a series of sequences where the input of one stage is the output of the other stage.
Yeah. I think that's the explanation for cascading lah. Because it must have a sequence. So sequence 1, sequence 2, sequence 3, and output of sequence 1 must be the input for sequence 2. So it doesn't matter how many levels you have. Okay, so for your opinion, how cascading can be used in pneumatic circuit design? Any idea? So any idea based on opinion? Any idea how to ini supposed to be a discussion ya. If saya seorang je yang bercakap, I think no point lah ada discussion. Try to answer. If you don't answer now, you need to answer in company later. Saya panggil nama.
Can I try, sir?
Yes.
Cascading meaning a various of signaling element be used for control sequence of pneumatic. From my opinion, cascading can be used when they have a signal developing in circuit, and so it can be used to prevent it.
Okay. So your friend say is based on the signal overlap lah. You can avoid the signal overlap. But based on the term, okay, so soalan ni dia ada kaitan dengan term cascading. So when you have cascading, meaning you can have a lot of sequence. So pneumatic circuit design pun ada sequences. Okay, one after one. So it not happen. Sebab itu kita tak ada signal overlap. So we want to avoid signal overlap. So when you have sequence, so you can utilize this cascading way lah dalam pneumatic. Okay, so what is the function of limit switches in cascading pneumatic design? Apa function dia? What is the function of limit switches in cascading pneumatic design?
Function limited in cascading pneumatic design can be as an input. I think a function of limit switch in cascading pneumatic design is for input for the design packaging to produce the output. That's from my opinion.
Okay, so limit switches are practically like your distance rule. Okay, so when your cylinder is extended and hit the limit switch, so a limit switch based on either magnetic or it will be electrical or mechanical. Selalunya mechanical lah, because you are using a roller. Okay, so once it hit the limit switch, so it will start another sequence. Okay, so that is the function of limit switch. Okay, so number 3, for your opinion, why we cannot put same alphabets? Okay, example A plus and A minus in the same group. Ya, ini soalan untuk cascading. So cascading, you will have a group changing valve. So you will divide your full sequence to 2 or 3 groups. Okay, kenapa A plus and A minus cannot be put in the same group?
And cause signal overlap.
Okay, so it can cause signal overlap because if when you put in the same group, you give a same actuation. Okay, maksudnya if group 1 active, meaning A plus and A minus will be active and it will cause signal overlap. Okay, kalau you dah biasa buat cascading lah, kalau you dah buat assignment yang saya bagi, so you will understand why we cannot put in the same group. Okay, so answer based on your opinion. Okay, kenapa? Okay, for your opinion, why the number of group changing valve must be number of group minus 1? Okay, siapa boleh answer? Kenapa group changing valve must be number of group minus 1?
I think
Any
because it acts
logical
as
answer?
I think it's because it acts as like the starting valve and it's not the valve that is involved in the changing yet.
Starting, maksudnya you tak dapat the keyword. Yeah, any other answer? Kenapa group changing valve must be number of group minus 1? Okay, kalau ada 3 group minus 1, so group changing valve will be 2. Kenapa? No answer. Jordan Ng can attempt this question.
Okay, so I think that for me, I understand this question wrong.
Okay. How you understand?
So
How you understand?
I understand the number of group 1, like one group.
Hmm? How we can be only one group? Because cascading must have a minimum 2 groups,
Yeah.
right? So maybe you can just based on your opinion, yeah. So no right or wrong. Why the number of group changing valve must be number of group minus 1? Any guesses?
Also,
Can I try, sir?
Yeah.
Because
Sure.
the Wafiq Haziq, Muhammad Wafiq Haziq. Because after the last group is the first group, the system will be in repeat.
After last group will
Will
be
be
first.
the first group.
Okay.
So the system will be repeat, and the changing while will be used is the first group changing while.
Okay. Still tak dapat the keyword. So I'm expecting some keyword. So Okay, thank you for the tries. Okay, so any other answer? Kita tengok siapa dapat keyword tu. The point lah. If you understand pneumatic, you'll understand this. Anyone else? I'll try.
So may I try?
Yeah. Anyone.
In my opinion, it because the output of group changing will become the input for group 1 and group 2.
Output of group changing. Okay. I think almost there. Boleh explain sikit? Sebab I nak check whether you betul-betul dapat ke tak. Yeah, Muhammad Fitri. Boleh explain sikit yang answer tadi.
Explain. Tak tahu macam mana nak cakap.
I think your answer dah dekat dah. A discussion not necessarily talk in English. We can talk whichever, because as long you can discuss, as long you can communicate. So just try to say whatever in your mind. So soalan pun basically based on opinion. I just want to check whether you understand or not. Ya, boleh. Mama Fitri.
When the group changes, tak tahu saya nak tahu.
Betul. Okay. Tak apa. Thank you. Yeah, anyone else? Ada siapa-siapa nak try? Amirul Shukri ada?
Saya ada, sir.
Ya, nak try? Boleh try.
Sorry, sir. Saya tak faham lah yang 4 ni.
Ya. Okay. Nak faham lah, kalau tak boleh buat cascading. So you need to understand this. Yes, apa? Lee Song Ki, yes.
I think for the circuit to change for this group changing valve to change between the group, like what first group on and second group off.
Okay.
So it can maybe the number of group -1 to make sure the cylinder can operate like not overlap.
Okay. I think nama lah, I bagi answer lah. I think mostly dapat, just you don't know how to explain. Okay, so the question is asking for your opinion, why the number of group changing valve must be number of group -1. So kalau number of group yang you set dalam cascading is 2, so group 1 and group 2, so your group changing valve must be 2 - 1, so 1. So cuma ada satu group changing valve untuk dua group. Kenapa? Sebab one group changing valve have two part, left hand side and right hand side. So kalau you nak choose group 1, you pilihlah bahagian kanan. Kalau you want group 2, pilih bahagian kiri. So one valve is enough to control two group. Sebab dia ada dua state. Dia ada normal dengan initial kan. So kalau normal, group choose group 1. Kalau initial condition, choose group 2. So maybe I will show lah dalam slide. I hope you dapat lah, dapat understand benda ni. Okay, kita boleh nampak yang ni. Okay, dalam solution ni, so you ada 4 sequence, A plus, B minus, A minus. Okay, so kenapa kenapa dipecah dua grup?
So it doesn't
Anyone?
cause signal overlaps.
So you want the word signal overlap. So you don't want to put the same sequence in one group. So dekat sini you letak same alphabet dalam satu group. Okay, so A plus, B plus dalam satu group, B minus, A minus dalam satu lagi group. Okay, so you ada berapa group?
Groups.
2 groups. Okay, so group 1 and group 2. Okay, so group changing valve equals to number of groups minus 1. Okay, so ada 2 group, so 2 minus 1. So you need 1 group changing valve. Okay, so sebab group changing valve equals to 1. Okay, so dekat sini you tengok. Okay, so you ada 2 group, group 1 and group 2. So kalau you nak choose, this is your group changing valve. If signal is given in number 1, dia akan choose group 1 lah dekat atas. Sebab udara akan masuk dekat sini, it will activate this group. Yang group 2 ni dia disconnected. Okay. If the signal is given in number 2, so group 2 akan selected. So whichever valve ataupun actuator ataupun push button or roller connected to this line will be activated. So untuk control 2 group, so 1 valve is enough. Because you can switch between group 1 or group 2. Depends on yang mana you nak select. Okay, so that was the reason why group changing valve equals to number of groups minus 1. So kalau ada 3 group, group 1, group 2, group 3, so number of group adalah 3. So 3 minus 1 equals to 2. So you need 2 group changing valve. Macam condition ni lah. Sequence ni. So tengok ada 3 group. Group 1, group 2, group 3. So dekat sini dia cuma ada example 2. Ada group 1 and group 2. So tak ada example lah, tapi kalau you cuba dalam your assignment you boleh understand. Dekat lecture note ni tak ada contoh. Cuma ada satu group changing valve. Okay. But that's the concept lah. Kalau you bagi input dekat sini, dia akan choose bahagian kiri. Kalau you bagi input dekat sini, dia akan choose bahagian kanan. Okay, so you can switch between group 1 and group 2. Okay, boleh understand?
Boleh sir.
Okay, so I hope you really understand lah. Yeah. So kalau tak, memang tak ada apa buat. Okay, so number 5. Why the group changing valve must be changed state before connecting the input to the DCV or cylinder B to retract. Okay, so yang ni I think example lah, example yang tadi. So kalau you tengok dekat sini, so you ada group. Sikit. Sekejap ya. Okay, boleh nampak? Okay, so soalan tu dia tanya, dia ada dua group, A plus dengan B plus, B minus dengan A minus. So the sequence is A plus, B minus, A minus. Dia tanya kenapa kena tukar group? Kenapa dia kena tukar state?
So that it can trigger the others limit switches.
Okay, so why group changing valve must change state? So group changing valves change state maksudnya dia tukar kumpulan. So dari kumpulan satu tukar ke kumpulan dua. So the answer is why the group changing valve must change state before connecting the input to the direction control valve for cylinder B to retract. Okay, so dia kena tukar sebab B minus. Cylinder B to retract is B minus. So B minus ada dalam group yang satu lagi. So every time you want to access something that is in the other group, dia kena tukar group. Group changing valve kena tukar state. So baru dia boleh boleh ada that you will access to the particular sequence lah. Okay. So maksudnya yang ni you actually boleh pecahkan dia jadi 4 group. Boleh juga. A plus satu group, B plus satu group, B minus satu group, A minus satu group. Boleh juga macam tu. So, but you need to have 4 states. 4 times you kena tukar line ni dia akan ada 4 times lah. Faham tak? Okay, boleh? Okay, so final question for cascading. Based on your understanding, what are the differences between cascading method and classical method? Okay, siapa boleh attempt soalan ni? So differences between cascading method and classical method. So what is the most significant difference yang you memang boleh nampak? Well, you dah biasa buat classical maksudnya you tak ada step-step lah. You start dari bawah, dari compressor, you design sampai actuator. So you don't have a particular method of designing. Cascading method you dah tengok, dia ada group changing valve, dia ada cara few steps lah that you need to follow. Okay, so based on your understanding, what are the differences between cascading method and classical method? Anyone can try?
Can I try it, sir?
Yes, can.
So based on my understanding, cascading method is a method of selection of input being used before delivered to the cylinder for the output, with more complex complex system. While classical method is more direct from the input directly to the output cylinder, and this situation can produce a signal overlap which two signals happen to the input and make the system fail. So that is my answer, sir.
Okay, thank you. So ada answer lain? Anyone else nak try?
Sir, can I try?
Yes, sure.
Yang saya faham, cascading method is easier to make system like automatic system rather than classical method.
Okay. So that's the obvious differences lah bagi pendapat you. Okay, good answer. So other answer? Anyone else nak try? It's okay, I akan bagi answer lah. Okay, so based on your understanding, so soalan tanya based on your understanding. Okay, so the differences between cascading method and classical method. So classical method, the main differences lah between classical method and cascading method. Classical method dia tak ada satu cara or step yang you perlu follow. Okay, as long you boleh design dari compressor sampai actuator without any problem, it's acceptable. So meaning you tak ada step 1, step 2, step 3, step 4. Dia tak ada some steps that you need to follow lah. Tapi cascading method, dia ada cara dia. So you kena determine the motion, dekat mana berapa group. So dekat mana you kena group change the group, berapa group changing valve. So dia ada cara dia. So you need to follow step by step until you dapat your answer. Okay. So maybe you ada soalan ni lah. Soalan ni I tertanya dekat sini. So kenapa nak buat cara susah kalau ada cara senang kan? So for you maybe you think classical method is easier, is more straightforward compare dengan cascading method yang ada banyak step. Okay. So maybe you tak nampak sekarang because you only controlling one or three cylinders. Tapi cuba bayangkan you ada 1000 silinder. 1000 silinder yang you kena control using circuit. So at that time, classical method will not be helpful. Sebab kalau you gunakan 1000 silinder, the chances of you getting signal overlap will be very high. So kalau signal overlap, your production line tak boleh jalan. Sebab dia, you know, when ada signal overlap, what will happen to the cylinder? Ataupun
Nothing
direction
happens.
control. Nothing happens. It won't move. So kalau tak move, so what will happen to your production line?
Stop.
Benda tak bergerak, you totally become dormant. So what will happen to your job then? You are fired. And the apprentice kan, you are fired because you don't deliver the job. So the same thing. So that's why you need to use a cascading way of controlling stuff ataupun step counter way. Sebab when your production line become bigger, classical method will not be relevant. Sebab dia akan, the main drawback of classical method, it will cause a lot of signal overlap. So cascading method, the differences lah, answering this question. So the differences between cascading method and classical method. So cascading method is more practical in a bigger system, since it can eliminate signal overlap so effectively compared to classical method. Okay, boleh faham?
Boleh, sir.
I hope you all get lah, understand apa yang kita belajar. Okay, so that's on the cascading method. Okay, ada apa-apa soalan?
No, sir.
Okay, so kalau tak ada soalan. Okay, so since last week kita ada dua. Okay, so this is not. Okay, so it's okay. I think okay. Boleh. It's okay. Okay, any questions on step counter method? Ada apa-apa soalan tak? Yeah, I think cascading method I dah explain. Step counter method ada apa-apa soalan tak? Yang I boleh answer.
Sir, I have a question. This is similar to your question in open-ended question about my opinion. Of 3/2 wave valve can be replaced in 5/2 wave valve. So I doesn't understand really about function of 3/2 wave valve in the step counter, sir.
Okay, so step counter ni dia actually, so you can see this.
Yes, sir.
Okay, so kenapa 5/2 valve tak perlu digunakan? Okay, so for step counter method, dia ada step counter module. Okay, so you boleh tengok dekat sini kan. So this is one module. So dia ada end valve. The end valve, you tahulah dia ada dua input. So dua-dua input dia on, baru dia akan send signal dekat sini. Okay. So kenapa 3/2 valve is enough? Kenapa not 5/2 valve? So what is the function of 5/2 valve? Siapa tahu? Kalau you dah biasa dengan design pneumatic, you understand the concept, you'll understand. 5/2 valve kita akan gunakan waktu bila? Anyone?
So double
As
acting
a group
cylinder.
chain, double acting cylinder.
Double acting cylinder, betul. So 5/2 valve you connect before your double acting cylinder. Tak perlu connect dekat sini. So dekat sini you just need to activate this line. So to activate this line, so, consider macam kalau ada signal dekat sini, so all 3, 4, 5 akan ada input. So you just need to have one trigger. So 3/2 is enough. So you tak perlu gunakan 5/2. Because you are not controlling a double acting cylinder, you are just activating this line. Okay, did I answer your question tadi? Ni siapa?
Ulazmi, sir. Yes, I understand.
So 5/2 or 4/2 kita hanya gunakan untuk sebelum your cylinder. So kalau tengok dekat bawah ni, tengok. Okay, so this is your module. Okay, step counter module. So, ada AND gate dengan 3/2. Tengok dia connect dekat 5/2. So you tak letak yang ni dekat bawah ni because you're only sending a signal. Dia cuma kena bagi satu signal untuk activate yang ni. So better to have a separate one. Okay, so any other question? Ada tak? The step counter method, understanding step counter method is equally important because soalan tu I boleh tanya, okay, design this circuit using step counter method. So design this question based on cascading method. Kita tengok, actually I dah overlap the presentation slide. Saya buka dekat advance. Tak boleh. I think it's important for me to be staff. Kenapa advance? Okay, in between kalau ada soalan tu boleh tanya. Okay, well, tadi saya set puzzle. Yul boleh masuk tak? Add puzzle. I think their server is down. Cuba dari tadi memang tak boleh masuk. Sorry, I couldn't get the question. Itulah. Maybe I will find another slot for you to check. It's okay, maybe next week kita akan bincang on step counter method lah. Okay, on the puzzle question. We just cascading dulu. Okay, so any questions before we dismiss? Final question ke ataupun
Questions.
okay, so announcement. Okay, baru boleh buka. Okay, I managed to find. Share dulu. Ya, tak apalah, tak perlu share, I baca just. Okay, for your opinion, can 3/2 wave valve in a step counter module be replaced with 5/2 wave valve? Why? Okay, so I think I dah answer tadi. Okay, kenapa kita tak perlu replace? Tapi soalan dia tanya, soalan ni dia a bit tricky. Dia tanya whether boleh ke tak boleh. So answer to the question, boleh ke tak boleh? Salah tak kalau kita ganti?
Tak salah sah.
Still will work as long you trigger betul-betul lah. Pastikan semua connection tu betul. So you just bagi 5/2. Kalau you ada banyak duit, you boleh lah beli 5/2 sebab normally 5/2 will be more expensive than 3/2. The purpose of dalam step counter module is only to give a trigger signal. So trigger signal you tak perlu gunakan sophisticated valve. Okay, so answer to this question, you may replace with 5/2, tapi it will be underused lah. So just untuk bagi signal, selalunya 5/2 or 4/2 kita akan gunakan untuk control your double acting cylinder. Okay, so that's the first question. And the second question, based on your understanding, what will happen if you connect input 3 to output port of the direction control valve? Yang ni based on input 3. Okay, so boleh tengok dekat sini. Input 3. So kalau you connect input 3 dekat direction control valve, so katakan you ada signal dekat sini. Okay? And input 3 pun ada signal. What will happen to direction control valve?
Signal overlap?
No overlap. Kalau ada signal masuk dekat sini, okay, I tunjuk dekat. Okay, so if the signal is entering here, what will happen to this direction control valve? That's the question.
It
It
will
will
be
trigger.
accurate.
It will accurate.
So it will actuate, it will activate the circuit, so it will change state. So kalau ada input masuk dekat sini, it will change state, it will execute this side. So if this side, what will happen? On your left hand side, kalau dia tukar state.
The valve will change positions.
Okay, it will change state. Then what will happen? Kalau dia tukar state ni, dia apa akan berlaku?
It causes the cylinder to actuate.
Yeah, the cylinder will start to expand. So that's the question lah. So if there is an input in number 3, sebab dia soalan tadi tanya number 3. So if there is a signal in number 3. Okay, so number 3 ni dia actually connected to your direction control valve. So if there's a signal coming in, your directional control valve will change state and your cylinder will start to extend. That's the answer lah. Okay, boleh faham?
Boleh, sir.
Understand, sir?
Okay. So the question also asks if your number 3 is connected to the other side, other port, other side. So what will happen? Macam ni lah, yang ni dia connected to this side. So what will happen?
The cylinder will be unactuated and cannot be triggered.
Function dia akan terbalik. So depends on where you give. So you boleh bagi dekat sebelah kanan ataupun sebelah kiri. Depends on your sequence. So if you want the cylinder to extend, you bagi sebelah kiri. If you want the cylinder, your sequence to retract, you bagi dekat sebelah kanan. Okay, so it depends on where you give. Okay, so the next question, what will happen if you connect push button to second sequence B plus instead of first sequence A plus? So A plus ada push button dekat sini. So what will happen if push button ni you letak dekat number 2, dekat B plus? So yang ni you tukar ke sebelah sini. What will happen?
Yang buat macam
Yeah.
you can activate cylinder yang ke kanan tu.
Okay, so what will actually happen? Here your sequence still start at A plus. Tapi A plus is directly connected to roller, so tak ada push button. So your cylinder A will extend, then it will activate this. So A1. So cylinder B akan tunggu your push button. Kan? Kalau push button ni ada dekat sini. Dia akan jadi macam tunggu input you lah untuk tekan. Baru cylinder B akan bergerak. Betul tak? Okay, so kalau push button ni tukar ke sebelah sini, so dekat sini tak ada push button lah. Okay, so A0 is active. Okay, so dia akan bagi input, your cylinder akan extend. Extend, which limit switch dia akan activate? Which limit?
A1.
A1. So A1 ni dia akan jadi aktif. Tapi dekat sini ada push button. So yang ni aktif, so you tekan je, baru your cylinder B akan extend. Betul kan? So the location of
the location of the push button indicates the point in the sequence.
it still will follow the sequence, but only the activation of cylinder B is upon a push button. Faham tak?
Faham, sir.
Okay, so the next question, why roller switch A0 and B0 must be in actuated state? Okay, kenapa A0 dengan B0 ni dia ada surface dekat sini? Ini actuated. Kenapa?
Sir, can I try?
Anyone? Yeah.
I think it's because it's connected to the A0 is connected to sensor, A0 sensor.
Okay. So A0 and B0 is a requirement for the sequence to start. Macam dekat sini. So it's a requirement. A0 kena aktif. Baru you tekan push button ada input. Kalau tak dari sini is disconnected. So similar dekat sini. So A0 and B0 is a state where the cylinder is fully retracted. So untuk sequence ni, so kalau you A0 dengan B0 tak aktif, so the whole thing will not start. So meaning yang ni adalah condition dia lah. So kalau condition dia A1 yang kena aktif, you letak dekat sini. Tapi pastikan kalau A1 aktif, in between tak ada apa-apa, so dia automatically akan execute this. So kalau yang ni at the retractor position and B0 is active, so dia bagi input pun, yang ni just sequence A minus. Meaning dia masih dalam retractor position. Tapi kalau B plus, yang ni aktif, automatically dia extend. So you need to be careful lah. So kalau yang ni sequence A minus and is active, still okay. Kalau B plus, you pastikan dia sebab tu you letak push button dekat sini. Sebab yang ni dah on, you tekan push button baru dia connected. Faham tak?
Faham sih.
Okay, so final question. Based on your understanding, what are the advantages of step counter method compared to classical and cascading method? Why? Okay, so final question lah. Kenapa step counter method is better than cascading and also classical method?
There is no signal overlap.
Okay, no. Tapi cascading method pun tak ada signal overlap. Dia tanya apa dengan classical and also cascading compared to step counter. Kenapa step counter lagi better?
It's more
Step counter
efficient.
more organized.
More organized, okay. So it's actually organized like for me. So I don't know about it can it can be argued. Tapi for me, step counter is more organized. Sebab dia arrange based on sequence. Sebab kalau sequence you perlukan A plus, B plus, A minus, B minus, you just change dekat sini, the sequence. And pastikan the actuation is given correctly. Follow the sequence yang you nak lah. So kalau tengok, if compared to cascading, so cascading dia ada line and other group changing valve. And the final design will be mana tadi? Tengok dia still nampak macam a bit complicated. You pun tak tahu yang ni kat mana. Tapi it still can eliminate the signal overlap. So as long dia boleh solve the problem, okay lah. Tapi kalau tengok cascading method, you tengok dia ada modul input dekat bawah, modul dekat tengah-tengah. So kalau ada 4 sequence, 4 modules, then ada input, ada output. Okay, the cylinder. So for me, it's more organized lah. So maybe for you, you prefer cascading. Okay. So for me, I prefer step counter because it's more organized and easier to manage. Okay, so any question? I think it's already 11 o'clock. So we sempat cover cascading and also step counter method. Okay, okay, ada soalan tak? Sebelum we dismiss. Okay, so kalau tak ada soalan, so the announcement. So esok ada kelas. So esok kita akan masuk electropneumatic. So ada cuma satu chapter. So we will learn that. Then please prepare for your midterm next week. I akan bagi tahu tarikh. So there will be 1 hour plus. 1 hour plus lah. So answering is 1 hour. So 2 questions. And then kita akan bagi masa untuk upload and download lah. Okay, so as usual. Then next week you need to submit your assignment. Okay, so I hope lab report 1 and 2 you dah submit. Okay, kepada Puan Usna. Okay, so this week and next week kita ada tutorial lah. So today tutorial 1. This week tutorial 1, next week tutorial 2. Okay, then kita akan resume balik our lab. The lab, so maybe minggu ke-8. So we will try to complete. So the next 4 weeks lah. Okay. So ada apa-apa soalan?
Questions,
So,
sir.
if no question. Okay, so no question. We will